Alright, so the final review pack here. Let's go ahead and start with significant figures. Determine the number of significant figures in each of the following numbers. So here we have zeros that are to the right of the decimal, but they're not terminating, which makes them non-significant. Here we have 3 non-zero digits. So that is 3. Here we have 2 non-zero digits, and then zeros that are not significant. Either they're not between significant digits or they're not to the right of the decimal and terminating. So that is 2. This is the first case we have a 0 to the right of the decimal and terminating. That makes, by default, this 0 between 2 significant digits, so that is a total of 4. Here, these zeros are between 2 significant digits, and everything else is non-zero, so that is 6. Between significant digits, so that is 4. This one, to the right of the decimal, but not terminating, so not significant. Other than that, though, this one right here, the definition of terminating and to the right of the decimal. So it's a total of 3. When you're rounding these numbers to a certain number of significant digits, I go ahead and I underline them, and then I check, is this 5 or higher? If so, then that's going to become 13.7. These don't count. These are the first 2 significant digits, so that's going to be 0, 0, 2, 3. And here I want 2. 14 is not good enough because this is 136. We need to maintain that value. So even though we only have 2 significant digits, we've got to put a 0 there to make sure that that is the same number, the same value. Multiplying and dividing with significant digits, you look at the one with the least number of significant digits. 3.0 divided, not divided by, 3.0 times 1.77.
The answer is 5.31.
So that's 5.31, but this only has 2 significant digits, so the final answer is 5.3. 0.137 divided by 0.0310.
The answer is about 4.4193.
4.4193, but we only have 3 significant digits there, so 4.42. 8.6 minus 3.
It's 5.6.
Now 5.6 any day of the week with a calculator. But the problem is that this only has a significant digit in the ones place. And that's how addition subtraction works. You only can go to the specific place value that your most or least specific answer is in. So the ones place, so this would round to 6. 2.38 times 80.
That would be 19.
2.38 times 80.
That would be 190.4.
190.4 with any calculator. The problem is we only have 1 significant digit here, so that's going to become 200. 22.5 plus 145.357 plus 17.
It's 184.857.
The problem here is that the 17 is only significant to the ones place, so this becomes 185. 185. Let's take a look at how to convert. So conversions, we do need to know a few things. You can learn these right here. You can remember every 1 meter is equal to 1,000 millimeters. Every 1 meter is equal to 100 centimeters. Remember that these milli and centa can replace, like you could say, milligrams. Every 1 gram is equal to 1,000 milligrams. Every 1 gram is equal to I wrote 1,000. I should have wrote 100. 100 centigrams. So keep that in mind. There we go. And every 1 kilometer or gram is equal to 1,000 meters. So it says convert 15 millimeters to centimeters. So we always start with what they give us, millimeters to centimeters. Well, up here we have every 1,000 millimeters. We're going to put that on bottom is equal to 1 meter. We'll put it on bottom so that this cancels out mathematically. Now we would have meters, and then every 1 meter, put that on bottom so it cancels out, is 100 centimeters. Oops, I canceled the wrong ones out. This one cancels out with this one. So 15 divided by 1,000 times 100.
would be 1.5.
So that is 1.5 centimeters. Same significant digits as what you started with. Remember, these both have unlimited significant digits because they are perfect amounts. 50 grams to kilograms. 50 grams, and we want kilograms. Or you know that kilo has 1,000 of the base units. So every 1,000 grams is 1 kilogram. 50 divided by 1,000.
It's 0.05.
0.05 kilograms. 45 kilograms to milligrams. 45 kilograms, milligrams. Well, we have kilograms. Every 1 kilogram is 1,000 grams. And every 1 gram is 1,000 milligrams. 45 times 1,000 times 1,000.
It's 45 million.
45 million. Excellent. So gram is a unit of mass. Liter is a unit of volume. And a meter is a unit of length. The formula for density we know as density equals mass divided by volume. Because density is how much matter is in a particular space. If a graduated cylinder contains 31 milliliters of water and an object is put into that cylinder which displaces the water, it now reads 38.5 milliliters, then what is the volume of the object? Well, we take the 38.5 milliliters and we subtract 31.0 milliliters. So, 38.5 minus 31.
It's 7.5.
7.5 milliliters. That object was placed into 31 milliliters of water and boosted the volume up to 38.5. So that is the difference between those. Calculate the density of an object that has a mass of 995.6 grams and a volume of 89 centimeters cubed. So we take the mass and we divide it by the volume. (995.6) divided by 89.
The answer is about 11.1865.
So we have three significant digits. 11.18 would become 11.2 grams per centimeter cubed. Alright, so you'll need your periodic table for this part. Are the following chemical changes physical or chemical? Are the following changes chemical or physical? So evaporating. Evaporating is a state change. You take a liquid and you change it into a gas. So that is physical because you could cool that down or condense that and it would be the same. Burning something is a chemical change. Crushing something, well, that's physical. If we crush wood, it's still wood, or a can would still be aluminum. Melting is a physical change. We melt ice, it's still H2O. Reacting is chemical, and mixing is physical. Give the formulas of the 7 diatomic gases. We have H2, N2, O2, F2, Cl2, Br2, and I2. Which group in the periodic table are the noble gases? That would be group 8A. Alkali metals, that's 1A. Halogens, 7A. Alkaline earth metals, 2A. Which state of matter can be described as lowest density? Lowest density means the least amount of matter per unit space. That would definitely be gases, which are compressible and expandable. That would be gases. Rigid would be solids and takes the shape of the container. That would be gases and liquids. Are the following properties characteristics of metals or nonmetals? Malleable as metals. Conductor of electricity and heat as metals. Shiny is metals. Forms positive ions is metals. And ductile is metals. Ductile means you can draw it into wire. Forms covalent compounds. That'd be nonmetals. Brittle would also be nonmetals. Use a periodic table to match the following elements. Cobalt. Cobalt is a transition metal. The transition metals are sometimes called B elements, and you can see cobalt's right here. Neon. Neon is a noble gas. Rubidium. Rubidium is right here. That's an alkali metal. Selenium. Selenium is over here, so that's definitely in the non-metallic group. And silicon. Silicon's on that line, so that is a metalloid. That's a metalloid. Also known as semi-metals. The atomic number. So the atomic number represents the number of protons. The mass number represents the number of protons plus neutrons. You could also say the number of particles in the nucleus. Which particles are found in the nucleus? Protons and neutrons. Charge of a proton is positive. Charge of a neutron is neutral. Charge of an electron is negative. So the nucleus itself is positive because it has the protons and neutrons. This number up here is known as the mass number. This number down here is the atomic number. So this atom has 17 protons. 35 minus 17
It's 18.
is the number of neutrons. We take 35 minus 17 to give us that 18. All sodium atoms have 11 protons. This is true. If we look at the atomic number on the periodic table, for sodium it is 11. Carbon 14 is an isotope of carbon with 14 minus 6, which is 8 neutrons. A sodium atom has the same number of protons as the same sodium ion. This is true. That's what identifies it as sodium, the number of protons. Sodium atom has the same number of electrons as a sodium ion. That is false. The fact that it is an ion means it's gained or lost electrons. A positive ion called a cation has fewer electrons than protons. That's why it's positive. Atoms become positive ions by gaining electrons. So if we take a look with our periodic table out, if it has 35 protons, its atomic number is 35. If it has 35 protons and 45 neutrons, we add that together, 35 plus 45. 35 plus 45, that will give us our mass number.
Here's what I found.
Come on now. 35 plus 45?
The answer is 80.
So that gives us 80 for the mass number. We find that 35, that element is bromine. The 35 goes on the bottom. 80 goes on the top. Let's see if it has a charge. 35 protons, 36 electrons. It has a charge of -1 because it has one more negative than it does positive. Cobalt. Cobalt has 27 protons, so its atomic number is 27. 60 minus 27? 60 minus 27?
The answer is 33.
So 60 minus 27 is 33 neutrons, the mass number here. The 27 is going to go right there. And since it has no charge, it has the same number of protons as it does electrons. 56 protons. 56 is the atomic number. This element is none other than barium from the periodic table. 56. (137 minus 56).
That would be 81.
Has 81 neutrons, and since it has a positive 2 charge, that means that it has 2 more protons than it does electrons. Notice we don't put any charge up here for the cobalt. 8 protons, that is none other than oxygen. has 8 neutrons and 8 protons, so the total number of particles in the nucleus is 16. That is the mass number. 2 more electrons than protons, so it has a charge of -2. Easy enough. Nomenclature. Write the chemical formula for the following compounds. Sodium is in A, nitrogen is in, sodium has a +1, nitrogen has a -3. So we need 3 positive ones to cancel out that -3 from 1 nitrogen. Ammonium sulfide. Ammonium is NH4, found on the back of the periodic table. Sulfide is sulfur, so S. Ammonium has a +1, sulfide has a -2. So we need 2 of these ammoniums. Problem is we need parentheses on that to make sure that that doesn't look like it says 42 hydrogens. Aluminium chloride, Al, Cl, we have +3 here, -1 here. So you can also do the least common multiple way. 3 divided by 3 is 1 aluminum. 3 divided by 1 is 3 chloride, or you need 3 negative ones to counterbalance that +3. Dinitrogen pentoxide. So this has the prefixes. So that tells us automatically there are 2 nitrogens and 5 oxygens. Iron 3 bromide. Fe, Br. This Roman numeral 3 tells us that the charge of the iron is +3. Charge of bromide from the periodic table, -1, right? So that means we need 3 -1s to balance out that. Magnesium sulfite. Mg. Sulfite is SO4, found on the back of the periodic table. Tells us here it has a -2 charge. Well, magnesium has a +2 charge, so that one's done. Barium phosphate. Barium is Ba, phosphate is PO4. And as it says, it has a -3 charge. Barium has a +2 charge. So the least common multiple of 2 and 3 is 6. 6 divided by 2 is 3 barium. 6 divided by 3 is 2 phosphates. Magnesium nitrate. Mg with a +2 charge. Nitrate is NO3 with a -1. So we need 2 -1s to balance out 1 +2. Hydrochloric acid, this is one you should just have memorized by, you don't have to worry about that for this test, but by the end of the semester you should know HCl is hydrochloric acid. And sulfuric acid, SO4 has a -2, hydrogen has a +1, so 2 hydrogens go in front. Alright, let's do the naming. Calcium. The first question you have to ask yourself is calcium in group 1A, 2A, silver, zinc, or aluminum? It is in group 2A, so we don't need a Roman numeral. Hydroxide OH can be found on the back of the periodic table. So that's simply calcium hydroxide. Nickel is not in group 1A, 2A, silver, zinc, or aluminum, so it needs a Roman numeral. S is sulfide. Sulfide has a -2 charge, so that means this nickel must also have a +2 charge. 2 times 1 divided by 1 is 2. NH4, that is ammonium from the back of the periodic table. Cl is chloride. Ammonium would never need a Roman numeral or anything. It always has a fixed charge of +1. Sn, that is tin. It does need a Roman numeral because it's not in group 1A, 2A, silver, zinc, or aluminum. O is oxide. So this would be 10. -2 times 2 is 4. Divided by 110. That is 10,4 oxide. Phosphorus is not a metal. So that means that we're going to use the prefixes. Tetraphosphorus. Decoxide. Boom, boom. Good. Down here it says balance the following by placing the correct whole number coefficient in the blank and match the reaction type. So I'm going to balance these first and then we'll match the reaction types. So anytime you look at this, you look and compare one thing from each side. You never want it to be hydrogen or oxygen first. Always leave oxygens and hydrogens till the very end. So here I have 8 S's. Here I have 1 S, so I need to multiply that by 8. Now that did in turn mess up my chlorines. 8 times 4 is 32. I have 2 over here. How do I make 2 into 32? I multiply it by 16. So if we take a look here, I have 3 oxygens, I have 2 aluminums, and now I have 6 coppers. Cl2, I already have 2 Cls, 1 Mg, I have 1 Mg, I'll have 6 O's though. So 2 times 3 is 6, so that means I need 3 times 2 to be 6. Down here, 1 Pb, 1 Pb, 1 S, 1 S, 2 acetates, so I need a 2 there, 2 H's, 2 H's. This is the hardest one of the day. 7 C's. So I'm going to start by putting a 7 here. 14 H's. So I'm going to put a 7 here. 7 times 2 is 14 O's plus 7 O's, which equals 21. Unfortunately, I cannot multiply anything by 2 to get 21. So 10.5 would be what you would have to put there, but you can never put a fraction there. It can never be half of a molecule. So even though this ratio works out, 1 to 10.5 to 7 to 7, we cannot keep it this way. The fix on this would be to go through and multiply everything by 2. So 2 of these, $21 of these, $14 and 14. So check it out. 2 times 7 is 14 C's. 2 times 14 is 28. 14 times 2 is 28. 28 plus 14, 42. 21 times 2 is 42. It all works out, and this is the lowest. There is no greatest common factor that can reduce this. So anytime you have multiple things becoming one, that is known as a combination or a synthesis reaction. Here we have an element aluminum. Here we have an element copper. Aluminum has come in and replaced copper. So this is what we call a single replacement or displacement. Here we have one compound and it is broken down into multiple things. That is known as a decomposition. Here we have 2 compounds and here we have 2 other compounds. So watch what lead has done. Lead has gone in and replaced hydrogen and walked away with sulfur. Hydrogen has then come over here and replaced lead and walked away with acetate. So that is 2 replacements, or a double replacement or displacement. Last but not least, anytime you have a hydrocarbon reacting with oxygen, it forms carbon dioxide and water. This is a combustion reaction. That's a combustion reaction. That's it. That's all that's on the 9 weeks test. Thank you, and have a great day.